All right. So, a thought before we get into our next topic. Um, Remember that chaos theory is something I heavily have believed in my entire life. Okay? All right? To the point where I don't see connections from concepts like jealousy. Okay? Because I just don't understand what how someone sees this as a method of handling a situation. Okay, um, and my focus is at another level. Okay, which means of the average person. Okay, meaning that when George, right, misses days of work, I don't notice George is gone because my day, guys, there's goals in my head. I'm on a mission. I'm trying to do things, and if I'm not working, I'm labbing. Okay, especially in the beginning of my career, I don't have time to worry about what George is doing. Okay, where everybody else is talking about, well, George is late again. Okay, all right. I'm at work 5 o'clock in the morning. I don't have to report it until 8. Do you know what I can get done in those 3 hours of nothing? Okay, first of all, I could leave early because I've definitely done more than 8 hours worth of work before that everybody else has. Okay, but everybody else comes in around 9 or 10 o'clock. Okay, or if they do come in at 8 o'clock, all right, they don't even open up their emails until 10 o'clock. Okay, where I've already my response to all the emails from the previous day. Okay, all that work is done. Okay, and I even had a good hour left after doing my work from to catch up from yesterday and respond to emails and things of that nature. I can read. I can laugh for an hour. Okay, priceless. Okay, now, but you know, these people come in at 8 o'clock and don't even start working. I mean, guys, in an office, there's always chatter. And you know what it's always about? Okay? Movies, TV shows, okay? And the game, football game, basketball game, playoffs, okay? All right? Oh, did you see the Emmys last night? Okay, and it's always a person not sitting at their desk, but standing next to the entry of their cubicle, okay, creating this communication and conversation with three or four other cubicles. Okay. Next thing you know, they're all standing at the edge of their cubicles. Okay. And now it is a networking event. Okay. Where now you have PCs connected into the same VLAN. All right. So, but with me, I it's from the average perspective, the things that people worry about in the office are not the things that I worry about, and I uh, am trying to make the point that when you're going through your studies, okay, the bottom line is chaos does exist. Things happen for no reason, and I'm going to tell you the best thing that Homer Simpson has ever said in his entire life is when he was talking to Bart. He's like, Bart, dogs or people just hate you for no reason. That is the most philosophical and truthful aspect, okay, from Homer Simpson's philosophical thought process that will ever come out of his mouth from the time of death, okay, of his death, and I'm telling you, all right. So keep in mind that chaos theory does happen. 9 times out of 10, you're sweating the small stuff. Don't sweat the small stuff. Okay. Now let's talk about access lists. Okay. Now, access lists. Okay. Before we talk about these rules, all right, This is what an access list is. Since I don't have it defined in here, access list is a list of networks, okay? Period. So, in my access list, okay, I have 10 networks listed in the access list, okay? It's called an access list, but what it is it's a list of networks that you have defined. And it's not just networks, it could be hosts. Sorry, I'm kind of banging on the table here. I just realized that when I saw my microphone gauge go all the way up to the red. I'm sorry about that. So now, okay, so access lists are nothing more but a list of nodes and networks. Okay? All right? Now, that access list could also have just the source IP addresses and networks that are in your list. Okay? Just the sources. Okay? So you're going to say access list, we'll give it a name, Kyle, okay, or a number, maybe 10, access list 10, all right, and, okay, all right, and that number is just saying, hey, this is access list number 10. That's all. These numbers are defined by you, the engineer, okay? So access list 10, okay, or if you want to make it simple, access list number 1, right? Network 192.168.1.0. 192.168.2.0, network 192.168.3.0. Those are the 3 networks in your list. Okay? And it's going to say that in order to match this a network in this list, it needs to be the source. The traffic needs to be coming from the source of 192.168.1.0, 2.0, or 3.0. Okay? Any IP address, okay, 192.168.2.16 is going to be in that list because it's matching the list. Okay? Remember, when you talk about the network, you're talking about the whole range of that broadcast domain, okay? The entire range. If it's a /24, you're talking about the entire 254 addresses, okay? All right, 255 addresses in that actual subnet, okay? Now, here's the thing, okay? Now, I can also say access list number 2, okay? Network 192.168.1.0, 192.168.5.0. Now that means that in that access list, if your traffic is sourced from 192.168.1 network or 2 network, I can't remember which one I said, and is destined for the 192.168.5 network, bam, that's a match. Okay? The entire range. Okay? I can also say anything coming from 192.168.1.20, okay, which is a host, all right, to 192.168.15.6, which is also a host. Once that traffic is defined, meaning that it came from that source to that destination, bam, in that access list, you have a match. Okay? I can also say anything coming from 192.168.1.1 to 192.168.2.1, okay, with a port number of 2000. You get my point? Okay? So I can be very specific with my access list, but don't get it twisted. Access lists are, regardless if you give it a name or a number, it is a list that you define via your configuration, okay? And it sits in the configuration as a list. That's it. Okay? It is not utilized at all. It is a definition that you have created as a list. So access list 1, 2, 3, 4, and 5 will have different networks, okay? Whether they're just source addresses or source to destination addresses or source to destination with port numbers, okay? The thing is, these are just the defining of the list, and it sits in the configuration, okay, as kind of like you storing flash drives in a drawer, okay? They're there. Now, how do we use the actual access list? Well, we will go under an interface, okay, and we will say like IP access list, right? And call for that access list number. So that command's right here, by the way. So let's say IP access list. Now this is under the interface. IP access list number 10, which we don't use the word number. We just say 10. Okay. All right. God, I can't believe I lost the command. IP access list. Inbound. I think it's inbound or input. I think it's inbound. Okay. All right. Inbound. So what you're saying is, look, I am going to apply access list number 10, okay, to this interface for all traffic that's coming inbound on this interface. Okay? Hang on. All right, give me 1 second. Okay, so when traffic coming inbound on that interface matches one of the access or one of the networks or hosts that is in your list that you applied to that interface, what are we going to do with the traffic? So now we got to go back to the creation of that access list, okay? Because in that access list of your list of networks and hosts, you say in the access list creation whether that network is allowed or denied. So that means now in the access list, you're literally going to say network 192.168.1.0, just a source address, right? Okay, but we're going to deny that traffic. Okay, next line is going to say network 192.168.2.0 is allowed. That's what's in the access list. Okay, now you have applied it. Okay, all right, keep in mind the access list is just stored in the running config. Okay, all right, or the starter config, because obviously you want that starter config to go into the running config and have your list defined. Okay, and doing an IP access list command under the interface and calling that access list by name or number, okay, you are saying deny 192.168.2 network and allow the one network. Okay, I'm sure I did that backwards, but you get the idea. So now, that is what an access list is. So let's talk about the rules of an access list. Okay, an access list, as traffic is coming in and you have an access list applied to an interface, every traffic that comes in that interface, okay, now keep in mind, you can have an access list apply for inbound traffic and outbound traffic, okay? All right. Okay, so now, so we applied it to inbound traffic. So every traffic that comes in, every packet that comes in our interface is going to look at the access list to see if that traffic is a match somewhere in that list. Okay? And if we find a match, all right, guess what? we're going to allow it or deny it as we did in our access list. Now, here's the thing, though. Here's the thing. What if I do not have anything that matches on that list? Well, at the end of every access list that you create, there is what is called an implicit deny, okay, that you don't see in the configurations, okay, meaning that if you create an access list and put it on and put it on an interface for inbound traffic, and you don't allow that traffic, and there's no match on the access list for that traffic, it gets denied automatically. Okay, so you're asked out. So sorry. Okay, so you have to go back into the actual access list, okay, and create a new entry for that network to be allowed, okay, which will go one step above the implicit deny, because every time you add something to the list, it goes to the bottom of the list. Now, you as an engineer can manipulate that access list, okay, by changing what is called a sequence number, okay, all right, and put the and put that IP address, or I'm sorry, put the IP address or the host address or the network, okay, address, and move it up from the bottom of the list as far as you want. Okay, now this is important because you gotta understand an access list as packets come in. Okay, it doesn't matter if we're coming in or not. It doesn't matter. As we are matching traffic, it starts at the very top of the list. If there's a match, that's where the access list stops, and it does whatever it's supposed to do on that matching, meaning permit or deny. All right. Now, if nothing is matched on the first list in that access list, it goes to the second one and it goes to the third. Okay. It will keep going down the list until it finds a match, and if it doesn't, that traffic is denied. Okay, off the jump. Okay, so there is a sense of importance, okay, because if I decide to deny 192.168.2.10 host, okay, all right, but above it, what did I say? I can't remember what I just said. I'm sorry. Let's start over. Okay, so if at the top of the list I say deny 192.168.2.0 network, and underneath that I say permit 192.168.2.10 host, what's going to catch first? The deny statement at the top of the list, because it's part of that actual network. So if you want to deny the entire network but allow a host, one IP address in that network to be allowed, you need to put that above the denying of that actual network. So that goes to the top of the list, or at least one level above it. Okay? So that traffic will be allowed and all the other traffic will be denied. You can't have it underneath the deny statement, because it will always match on that host to be denied, regardless of how many times you put it to be permitted in the access list. So it has a top to bottom hierarchy. Okay? All right, and it denies all at the bottom of the list, meaning that if I create an access list and I have no IP addresses in the access list, okay, and I apply that access list to the interface, I deny all traffic. Okay? All of it, because of the deny all, or the implicit deny at the bottom of the list. Now, okay, one of the things that I am doing, okay, is, matter of fact, I can just show you. So, boom. 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 Okay, now, so these are my loopback interfaces. Now, don't worry, I'm gonna show you which will be another video, but I'm gonna show you how to import this information from this notepad into the run configuration instead of you have to paste all of this. Okay, so I have been building this for the last couple of days. Okay, so all it is I just do like 20, 30 lines. Then I'll stop and I'll come back later on, do a couple more, another 10 lines. All right, so right now I'm at 140 lines. Okay, and I still have 115 to go. All right, so we're going to do 255 loopback addresses and 255 subnets. Okay, all right, because this is going to be, the third octet is going to be the one that we're matching on. Okay, and as we are denying traffic, okay, we're going to find out how exactly what networks we have applied with our wildcard, which we're going to talk about in a minute. Okay, now, okay. So, location and direction of a access list makes a difference. Now, when we say location, okay, all right, it depends on what interface you put things on, okay? So, if I am connecting to a core switch that all our devices connect to, okay, if I put an access list on the main link that goes to the core switch, okay, I can affect the entire flow of traffic. That is the only path for that traffic to get out of, okay? Or if it's multiple paths, it doesn't matter, okay? Because that traffic might choose that path, all right, as the routing protocol decides that path is the best, and that traffic is now pushing traffic into an interface where that traffic is denied. So location does matter from that perspective. Okay? All right? So yeah, it's like I said, everything in networking is not simple. Okay? It goes as deep as it needs to be, and you as an engineer, okay, decides what part of that is important. Okay? And direction is important too. All right? If I have a router going into a server farm, okay, all right, and I put an access list for certain hosts to be denied and allowed, all right, in the inbound direction of that interface, you gotta understand that the only way for the information in the server farm to go through the router is to go inbound on that interface. Okay? So maybe I don't want to block traffic going inbound. Okay? Maybe I need to block it going outbound. So anybody coming to talk to that information, I can do the filtering on the outbound traffic of that interface, and that allows all the server information to have a way out. Yeah, it's that, I don't know how to put it, real, okay? Because there's a thought process to it, all right? You need to understand why you're doing it, not just because not just going and doing it, but you got to have a reason why you're making the choices that you're doing, okay? All right? So, access lists. What are some of the things that it is used for? So, let's look at it like this. Okay. All right. Help desk. Help desk. These people are notorious for bringing the network down because of their YouTube traffic. All right. So what we're going to do is we're going to set up quality of service. Now, bear with me here. Okay. You don't need to remember what I'm about to say, but think of the logic. Okay. So in quality of service, okay, I can create classification, okay, all right, and we use class maps to do that. So I'm going to say class map, okay, class map um, help desk. The name of the class map is called help desk. Okay, now I'm going to say match on the access list number 1, and in access list number 1, okay, that is network 192.168.1.0, the whole subnet for the for the help desk department. Okay, and now I'm going to say, okay, set the maximum bandwidth to 20%. Okay, all right. Okay, so maybe I'm not really just matching on the access list. Maybe I'm also matching on the access list and HTTP traffic. All right, so that means as they are accessing services on the server side to download files, they get full bandwidth. But once they go to YouTube, they're only getting 20% of the bandwidth. Okay, all right. So that is what an access list can be used for. Okay. All right. Now, let's say I'm using that. Okay. All right. Now, by default, you cannot send out traffic to the internet using private IP addresses. The ISP should block all IP addresses. Okay. Even if they allow the IP address to go through, okay, meaning that in their routing table for the internet, and the internet routing table shows private IP addresses, okay, all right, it's still going to go nowhere, all right, because you're not advertising. Oh, I'm sorry, you're advertising, okay, but at the same time, there's some, because other ISPs are blocking those addresses, your ISP forgot, so your traffic's still not going to return anyway. All right, so you get my point? But we use NAT, which is called Network Address Translation, to say anything coming from 192. Okay, hold on. All right, anything coming from access list 1, which will be 192.168.1.0. Okay, all right. In that access list, what I want you to do is every packet from that network, I want you to change the source IP address from 192.168.1.0 network to the public IP address that was given to us, all right, from the ISP, because that IP address is sitting on your interface where the traffic's going out. So that means all the return traffic from the actual servers on the internet are going to come back to you, and then it's going to be in that destination. It's now going to be translated back to the 192.168.1. whatever address. That's NAT. Okay, it uses a table to do this. Okay, route filtering. Route filtering is the concept of filtering routes. Okay, so and permitting and denying traffic. Okay, so I could actually say that, look, for my EIGRP, all right, for routes coming into EIGRP, my EIGRP domain, now remember, it's a per router perspective. Okay, it's not, it might be an entire domain, but remember, every router is its own entity, like every switch is. Okay, all right, now, so routes being learned from my EIGRP neighbor, okay? All right? Anybody that's in access list number 10, okay, I am going to filter that route and not allow it to come into my routing table as an EIGRP route. That's route filtering. But as you see, you're using the access list to define your hosts and your networks. Okay, you can have access lists sitting on your router that you never use. Okay, all right, and your list can be huge. All right, okay. Now, what is a wildcard? Okay, so if I say access list 1, network 192.168.1.0, okay, a wildcard is going to say, because you're going to say 192.168.1.0, which is the network number, space 0.0.0.255. This wildcard is what we call a reverse mask. So instead of saying a subnet mask, which would be 255.255.255.0, your wildcard is going to be 0.0.0.255. And what that means is when you set 0 in the first octet, that means the number that's in the network number has to be 192. I put 0 in the second octet of the wildcard. That means 168 has to match. Okay, third octet, same. But if I put 255 in the last octet, that means it could be any number. Nothing has to match. Okay, but a subnet mask for that, for identifying the actual network number and broadcast number, is going to say 255.255.255.0. Subnet mask is not a wildcard. But in my access list, I can use wildcards saying that the first three octets, okay, are set to 0. That means it must be a 192.168. That's one network number, okay, and the last octet could be any number. That's why we set it at 255. Okay, we're doing what is called a reverse mask, and it's called a wildcard. Okay, which when we do a lab, you will see that. Okay, now we have standard IP addresses. The standard access lists. We have standard access lists. They only match on the source. Okay, and we use the wildcard, okay, to say which network numbers need to match, okay, in my statement, and which ones I don't care about. All right, now an extended access list will match on the source and destination, or source and destination and port numbers, and also with a wildcard. So your first number in the access list is going to be your network or host, okay? All right. If I was going to use a host, it would be all zeros in the wildcard. Make sense? Okay. So now, if I have a wildcard and I say, all right, so hear me out. Access list 10, network 192.168.1.0, wildcard, okay, which you're not typing in the word wildcard, it's just a space and then you put the wildcard in. 255.255.255.255. What have I just done with that statement? Okay? I'm saying that the wildcard of all 255s means any number whatsoever. So, if in my access list I am denying this network, okay, what I'm doing is denying everything. Because every octet has a 255 in the wildcard, and that means all possibilities. Okay, so you just denied all traffic. All right? We're not going to talk about reflective because I'm going to have to go back because I literally have forgot what reflective is, but I have an idea, but I have to go back and look that definition up, which is why we're doing this, right? To figure out what I have lost over time and go back and relearn. All right. Now, when you type in the word access list, you only have the options of numbers. Access list number 1, 2, 5, 10. Okay. That's all you get. But when you use the command IP access list, okay, you now have the option to use a number or a character name. Okay. With special characters like underscore, right? So if I say IP access list, I can say IP access list Kyle, and now the name of my access list is Kyle. Then I can go back into my interface and say, IP access Kyle inbound. Okay, does that make sense? All right, now, here's the thing. There is something that a lot of engineers forget, and I'm guilty of it too. And at the end of the uh, access list definition, there is a log command option. And what this does is whenever something is matched on an access list as you are applied to an interface, it gets logged in your history. Meaning that you can actually go and say show logging, and you will see that traffic being allowed or denied in the actual output. A very good habit to start doing if you are looking or troubleshooting and looking for traffic, or you just want to know and want that. Now, keep in mind, now, if you're doing this for everything, your log messages are going to be overwhelmed with log information for transit traffic and not for things like, your fan is overheating. I mean, the log message is going to still be there, but it's going to be drowned out by pages and pages and pages of IP traffic because you're logging it all. So use it wisely. Okay? All right? Now, be strong, be determined, be Cisco.